Dear student, today we are discussing the class 12 level chapter and the chapter name is product of vector, and this is the first part of this chapter. Today we are discussing 6 topics one by one, and the topics are: first topics is introductions, second topics is scalar or dot product, third topic is projection of vector on a line or on another vector, and the fourth is properties of scalar product, and the fifth is vector or cross product, and the sixth is the properties of vector product or cross product. So one by one we are discussing the first part of this chapter, that is a product of vector chapter. In this chapter, that is a product of vector chapter, at first we are discussing the introductions. In this part, that is the introduction part, there are two types of product is there. One is dot product or scalar product, and another is cross product or vector product. And A vector and B vector dot product is symbolically expressed as A dot B, and A vector and B vector cross product will be expressed as A cross B. So this is the two product of vector. One is dot product and another is cross product. This is a complete of first part, that is the introduction part. Now we move to the next part, that is the scalar or dot product. This one, the scalar or dot product. Suppose A is a vector and B is another vector. Then the dot product between A vector and B vector is A dot B, and this will be mod of A vector multiple with mod of B vector multiple with cos of theta, whereas theta is the angle between the two vector A and B. So A dot B is only magnitude is there, no direction is there. That is, this is a scalar quantity. That is, a dot product is a scalar quantity. That is why we have say that this is a scalar product. In that part, that is a dot product part, we are discussing only magnitude. This is a complete of second part. Now we move to the third part, that is the projection of a vector on a line or on another vector. So move to the third part. The third part of today's discussion, the projection of a vector on a line or on another vector. So first part, on a line, suppose AB a vector. Any kind of vector AB is there, and theta is the angle between the vector AB is the extended AB and the straight line L. Then AM is a parallel to the L. Then we can draw a perpendicular this to the line L, and here also BB dash is perpendicular to L and AA dash is perpendicular to L. Then the projection of AB vector on the line L is A dash B dash. That is the mod of AB vector multiplied with cos of theta, whereas theta is the angle between the vector and the straight line. So this is the complete of first part, that is the projection of a vector on a line. Now we move to the next part, that is the projection on another vector. Suppose A and B is a two vector, and the angle between these two vectors, that is the A and B vector, is theta. And now BN is perpendicular to the A vector and MA is perpendicular to the B vector. Then we can say the projection of A vector on B vector will be A dot B divided with mod of B vector. Similarly, the projection of B vector on A vector will be A dot B that is a scalar product of A and B vector divided with modulus of A vector. So this is the projection of B vector on A vector, this one, and this is the projection of A vector on B vector, this one. So this is the complete of the third part of today's discussion, and we move to the fourth part of today's discussion. Fourth part we are discussing the properties of scalar product. Suppose A and B is a two vector, then A dot B is always equivalent to B dot A. This is always true for any two vector A and B. And the next part we are discussing, if A dot B or B dot A is equal to 0, then A and B vector parallel to each other. So this is a condition. That is, if A vector and B vector dot product is 0, then we can say the two vector A and B perpendicular to each other. So this is the condition. And for this, any three vector A, B, C, this is always truth. And now move to the next part. B plus C dot product with A vector, then you get. So move to the next part. For this, A plus B square of this, we get A vector square plus B vector square, and 2 times of A dot B vector is always true. And for unit vector I, J, K, this is the unit vector along x-axis, along y-axis, along z-axis. This is the unit vector. Now, from this, I dot I, J dot J, K dot K is equal to 1, and I dot J is equal to J dot K is equal to K dot I is 0, and these all are the cap because this is the unit vector. This is the complete of fourth section of today's discussion, and now we move to the next section, that is the vector or cross product of two vectors. Now we are discussing the fifth part of today's discussion, that is a vector or cross product. Suppose A and B are the two vectors, then A cross B equivalent to mod of A vector multiple with mod of B vector multiple with sine of theta and multiple with n cap. Whereas n cap is a unit vector along A cross B, and this is a vector product. That is why we are discussing this vector or cross product. That is, a cross product is a vector quantity. There is a direction and magnitude, both is there. And this one only magnitude is there, and this is a magnitude and direction, both is there. Whereas theta is the angle between these two vectors, that is this one. If A vector is there, if B vector is there, and theta is the angle between these. This is the complete of this section, that is the vector product section. And now we move to the last and the final section, the properties of vector product. Now we are discussing the sixth part, that is the final part of today's discussion, that is the properties of vector product. In this part, if any two vector A and B vector, then A cross B is not is equal to B cross A in general. And second part, that is A cross B is 0 vector. This is not the 0, this is a 0 vector. So these two vectors, A vector and B vector, may be parallel to each other, or A vector or B vector in a same line. Now the next part, that is A cross B plus C vector, then A cross B plus of A cross C, and similarly B plus C cross product with A, then we get B cross A plus this one. Next part we are discussing, suppose I, J, K is the unit vector along, this is the x axis, this is the y axis, this is the z axis. Then I, J, K will be that sequence. That sequence means I cross J will be K and J cross K will be I, and K cross I will be J. If any sequence is break here, that is J cross I is there, then this will be the minus sign. Similarly, K cross J is there, then this will be the minus I. And here also I cross K, then this will be minus of J. And this is a symbol of unit vector, that is a cap. One special condition we are discussing. How can we find the angle between two vectors? Using these two formula, we can find the angle between these two vectors, that is the angle between the vector A and B. So this is a complete of today's sections. Hope today's discussions and the example will help you to understand this chapter better. And when you practicing this chapter for your board exam as well as the competitive exam, this video enrich your knowledge about this chapter and help you to solve this kind of problem in your exam, that is the board exam as well as a competitive exam.